Alright, our background music today is Shout by Tears for Fears, and our section is Proportional Reasoning, which should also be very familiar from geometry. So we've got 4 vocab words. These should be very much review, so feel free to not write them down if you know what all of these words mean. I'm just going to run through them quickly as a refresher. So our first term is ratio, which is a comparison of 2 numbers. Notice the different ways that we can compare our numbers. The first is as a fraction, which is the typical way you'll see a ratio. And the second is using a colon. So when you use the fraction, you give kind of the whole with your denominator. So 1 out of every 2. So for example, 1 out of every 2 people is a boy. Whereas the second one, a ratio of 1 to 1, says there's 1 boy to 1 girl. So it doesn't give you the total, so be careful that you understand the difference in those 2 ways to represent your ratio. Proportion is 2 equivalent ratios. A ratio with 2 different units. Most common example would be miles per hour. Those are the 2 units, the miles and the hour. And then similar figures, of course, you remember this, same shape, different sizes typically. Technically, 2 triangles that are the same shape and the same size are similar. I call that more specifically congruent. I really don't use that definition of similar. So the first thing we're going to do is solve a few proportions. The most common way to solve a proportion is to cross multiply. So I'm going to take my 1/3 times t equals my 3 times 6. Dividing by 1/3 or multiplying both sides by 3, I get a solution of 54. Another way to solve proportions, you do not always have to cross multiply. Look at your numerator in this case because that's where both my numbers are. There aren't any variables in the numerator. And notice the relationship between the 2. -2 times -4 gives me 8. That same relationship must hold in the denominator in order for that equal sign to be accurate. So I can take x plus 5 times -4 to equal my x minus 3. So this will end up saving me 1 step when I solve the proportion. So for those of you that are so ingrained with cross multiplying to solve your proportions, yes, feel free to cross multiply. Make sure, as you see that I've done, you use those parentheses before you cross multiply. In this case, if I divided both sides by -4, I'd get a fraction in front of my variable, so I'm going to go ahead and distribute instead. Combining my like terms, adding 4x to both sides because that has the smaller coefficient to keep the coefficient of my variable positive. Adding 3 to both sides. And dividing both sides by 5. Our next example, we're going to use our UPS check. So I know that a 15-minute call costs 17 euros and $1 equals 82 hundredths of a euro, and I'm looking for the cost per minute in dollars. So what I notice is that I'm going to have some unit conversion. I'm currently in the euros unit and I want to be in the dollars unit. So when we do that, we need to set up a multiplication problem as opposed to an equation. So I want cost per minute. So I'm actually going to flip my first ratio around because I want euros per minute. Per means divide. So I want that division symbol, that ratio. And then in order to convert to dollars, I want my euros to cancel. So if I have a euros in the numerator in my first ratio, I want it in the denominator in my second ratio so that those units cancel. And then I'll be left with dollars per minute. So I've got $1 per 82 hundredths euros. And when I multiply those, sorry, I had this worked out, 17 divided by 15 times 82 hundredths gives me, and of course I will round, sorry, this is now on the solve step, to the nearest penny. I have $1.38 per minute. Make sure that you label your answer. We had 2 units after the euros canceled in our setup, so we need both units in our answer. And then to check, does it seem reasonable? Does $1.38 per minute seem like a reasonable cost when you're making a call internationally? And yes, we're not being charged $10 a minute, we're not being charged 3 cents a minute. $1.38 seems reasonable. Another way to approach this problem would be to actually convert the cost per minute in euros. So 17.15 would give me, sorry, I was gonna write a dollar sign because I'm so used to those, $1.33 per euro. And because the euro is stronger than the dollar, meaning the dollar costs more than the euro, this answer should be greater. So that's another way to check, is to think about your conversion that way.